All right. So hey, who here is from the Bay Area? All right. Anyone in town for SF Tech Week? All right. All right. I have to say, like every year at SF Tech Week, I think it gets more and more Web3 heavy. There's a ton of events this year. I feel like I'm at some big crypto conference. So good stuff, right? All right. Probably has something to do with this AI, crypto crossover, which driving a lot of innovation. So hey, I'm talking today about proof of encryption. Okay. Who here is interested in privacy, confidentiality with blockchain transactions? Okay, cool. I think it's a hot topic. It's kind of the next frontier. Uh, Today I will be talking. First, I'm going to give you a little background on Scale, so you know who I am, what we're working on. We've been around for a long time. Uh, Kind of talk about why privacy matters. I think there's some obvious things, but also some non-obvious things, and also some things that are misunderstood. Also going to talk about proof of encryption, give a technical overview. What is this? How is this working? How does this function? How does it do all these things it's promising to do? Also going to talk about use cases. I think often in tech talks and blockchain talks, you get a lot of like tech, but not a lot of like, okay, well, how is this actually going to be utilized in the real world? And that's probably one of our main growth areas as an industry is just getting these things more into the wild, more into use. There's so much innovation happening, but at some point you gotta deliver and reach the masses. Sorry, got a little clicker problem here. Okay, there we go. Okay, a little background on Scale. So when people say, "Hey, I don't know what Scale is," I say, "Well, we're top five of all blockchains and L2s in transaction volume and unique active wallets." Okay, so there's a lot happening in the ecosystem. This is primarily due to gaming. We have some huge game brands using Scale. There's hundreds of games on Scale. We're also deep in AI, decentralized social. You think about high volume, high throughput applications with lots of users. Okay, where cost matters. We also are known to build fast blockchains. So there's, I think, 16 chains in the Scale network now, but Dartmouth did a study, like real world study, pinging these blockchain networks, and Scale performed faster than in real life testing environment than Solana and Avalanche and some other, big well-known chains. That being said, we've been around since 2020. Okay. Um, Back then, everything was the holy grail was speed, cost, efficiency. We've kind of done that. And so, as a project that's not new, we started in 2018. We're constantly still trying to evolve. And what we saw was a need for privacy, and we started hearing this from people, and it actually suited a lot of the dynamics and structure of the network. This is my thoughts here. I'd love to, some people have probably some differing opinions depending on your lens of the industry. But, back in 2015, it was all like, how do we get smart contracts out there? And we were like, it was about decentralization. It was about security. And, it was really like cypherpunks and early enthusiasts and like token traders. That was the market, right? Then 2020 came around. We had this next push, and it was like DeFi summer, Web3 apps. And it was, how do we get performance and costs down? We had CryptoKitties broke Ethereum in 2019, right? And it was, so there was a race for performance. Now I see such a push with privacy, agentic enablement. Really, we have financial institution and enterprises. The stablecoin talk earlier, I think, is a good example too of like mass adoption in these industries, and I think more established players. Okay, so the barista test. The barista test is something. Actually, somebody told me this a few weeks ago. I was like, I'm gonna use that. So when you go buy a cup of coffee, let's say 2 years from now, we all have stable coins in our phones. Everybody. I mean, we might, but our friends who aren't crypto people are going to have them. If we live in that world and you buy a cup of coffee, these two guys, they look like pretty nice guys. Okay, like I intentionally grabbed this image, but do you want them to have your net worth, your core address, be able to track, how much money you have? Like, probably not, right? So I think we need to live in a world where you can buy things with stable coins and not expose your assets and what you own, and also do it in a way that's decentralized. Okay, so privacy is the next frontier. We want to support individual private transactions, like just being able to buy a cup of coffee. DeFi enablement. I'm going to talk about DeFi and how this plays a role in DeFi. Banking, payments, B2B adoption, agentic transactions. All of these categories can benefit massively from encryption and privacy. Real quick, what privacy isn't about, and I think it's often misunderstood, it's not this tornado cash world where we're trying to support bad actors to be able to obfuscate what they own, or help people avoid taxes, help people launder money. That's not the goal, okay? And there's so many real world business use cases. I've talked to someone the other day building a neobank that wants to use stablecoins, and they're going to launch this in Africa, and they say, we don't want, people aren't going to send money to their friend if their friend's going to be able to tell how much money is in their account. Like, we just need to have some elements of privacy. So, and I also want to say privacy and compliance aren't mutually exclusive, okay? And there's ways that you can give access, through cryptography to certain institutions or individuals. So let's say the FBI wants to see some piece of data. It's not fully mutually exclusive with having a 100% private environment. And I think for builders, you see builders being thrown in jail that do privacy work. I think it's important to have these compliance angles handled. All right, so let's talk about proof of encryption. So a lot of privacy solutions sit on top of a blockchain, okay? One of the issues is then, if you're an application, you show up and start using it, you can't use this unless you specifically integrate with this bespoke privacy solution. And it requires a lot of extra work, process, UX challenges, often a lot of latency because you're operating above the consensus layer. That's one of the biggest issues. Higher costs, performance and reliability issues, transactions failing. You're not at the level of consensus. And also, it just adds another arena for security vulnerabilities, okay? So we have the consensus that really is in charge of security, and then we have this other layer on top of it where a lot can happen, okay? It's just very complex. So what proof of encryption delivers is an integrated solution where blockchain is fully encrypted at the consensus level, okay? So the nodes, when they're actually validating transactions, aren't able to see information and take advantage of it and front run, sandwich attack. It also benefits the end user, which I talked about earlier. The thing that's nice about this that we're finding, we're in testnet now with this, public testnet. People are liking the fact you can just show up, deploy your EVM code, and take advantage of privacy and not have any MEV. So no performance issues, latency, reliability, failed transactions. It's the consensus completes, transactions finalized, so is the privacy, okay? It's out of the box, like I said, just deploy your EVM code, no additional costs. And again, you're just relying on those nodes and consensus as your primary security parameter, or as opposed to a completely adjacent product that is the intermediary between your users and their transactions. Okay, so how do we do this? So Byte protocol, something my co-founder, CTO, Stan Kladko, came up with. Stan was one of Dan Bonnet's students at Stanford and was on the founding team of a cryptography startup with him in the late 90s. He's a physicist as well. So you can see we have the BLS, which is Dan Bonnet's, one of his, he and some other people's invention is a core part of this. But Byte stands for blockchain encrypted threshold encryption. So one, BLS is a core component of this, and please take a look at it, threshold cryptography. Also, we utilize trusted execution environments. So trusted execution environments are secure enclaves inside of each node. So the validator is running a node. However, the validator can't see everything because we're leveraging this secure, essentially partition component inside of that server to store confidential information. We also do some things with distributed key generation to help make this work. In a typical blockchain, the transaction goes right to the nodes. The nodes have the full list of transactions, and then that's where all the gamesmanships begin, being able to sort things, reorder things. There's really no way, unless you try to, like I said, with some add-on or intermediary solution, try to integrate confidentiality between the transaction and the node, there's really no way to keep things confidential or private. With Byte, you have a transaction. The transaction's then encrypted in advance. Then it goes to the node. The node then is ready to process the block. The node's able to still validate that, hey, all this information's accurate without seeing all the information and being able to manipulate the information. Then consensus happens, and then in Byte phase one, the information's then unencrypted, it's decrypted, and you can still see all the information. If the barista test in that case wouldn't work because you can still see the information. Byte phase two has an option to actually keep the transaction fully encrypted and have configurable parameters so that you can determine what's private, what's not private, what set of things are private, and really let developers utilize blockchain in a way that meets their privacy goals. I'm not going to get into this today, but there's a lot of math here, a lot of process, again, using the ingredient parts that I mentioned earlier. We have a white paper and a light paper. If you're interested in reading it, you can go to fairchain.ai and check it out, or just go to Follow Scale. I'll show you later some links. All right, is this making sense? Okay, great. So let's talk about use cases. So when we look at the DeFi market, we feel like we're just scratching the surface, okay? What are the main things we do? We do automated market, AMMs, lending protocols. Those are a lion's share of the DeFi market, okay? But you talk to advanced builders, they want to do, leverage CLOB or limit and have, close limit order books and have limit orders. They want to be able to compete on par with centralized exchanges in a decentralized world. Well, if you have a limit order now, that's going to be completely taken advantage of, okay? You have this limit order, well, guess what? Every node sees that. You're going to get front run. On-chain indexes with rebalancing are something people want to do. So being able to have an index that is able to rebalance without getting, constantly front run. And you think about how often an index needs a rebalance. And one of the challenges in a decentralized environment now is just you lose a ton of efficiency, all right? You lose, there's slippage. It's just hard to maintain, a good economic advantage when you're constantly losing out to bots. Enterprises. So we talked to big enterprises, institutional traders. Well, guess what? They're not used to having MEV in their trading environments, and they're not used to having smaller set of functionality. Agentic AI. So talk to people doing agentic AI trading. And, the reality is you talk to a normal user and you say, hey, do you care about MEV? They don't care. I lose a few cents here and there, a few dollars here and there. But you talk to an AI builder who's like doing agentic DeFi, and instead of that one person doing 5 or 10 trades a month, that one person might be doing 5,000 or 10,000 trades a month, okay? Through their agent. But the cost of MEV, if you're losing X% each trade, it just goes up in aggregate as trading volume goes up. Also, we have people that want to put more advanced on-chain logic. So they want to have trading strategies that aren't just one trade, but has if, then, this. And if that information is all public, these strategies won't be able to operate. All right, again, we think MEV, there's a lot of different opinions here, but I think MEV, we feel like does not add value. But it's not been something we've had an option to to work around in the past. So we think it breaks DeFi. We think it hurts agents. and it stifles innovation at the enterprise and institutional level. Whoops. All right, got some clicker issues today. All right, so again, removing MEV from DeFi, enabling agentic AI at scale in DeFi, having advanced on-chain strategies, neobanks with privacy, B2B enablement, global payments with privacy. You think about all the payment use cases that will be more and more accessible with privacy. You think about compliant private trading, prediction markets that all of a sudden aren't being front run, that don't have to deal with MEV. And the last thing here is X402. So who heard the X402 talks earlier? Yeah, they were great, right? And I went to the happy hour last night. It was one of the best crypto happy hours I've been to in a long time, or just meetups in general. There's a lot of smart people, good conversation. There's a lot of energy in the X402 builder space right now. But I'll be really quick because I know a lot of you just heard very long presentations about this, but it's an internet native protocol for payments. It's leveraging the HTTP 402 status code. And it's kind of cool that this thing's just been sitting here dormant for X number of years. No one's really been using it. Like, hey, now's the time. Our team's been really active, in the open source community with X402. We've had a ton of pull requests across different platforms. We're building products, and we're building that because, one, we believe in it, but two, we also see a really strong fit with privacy. Here's our guys, our buddies, the baristas. Well, in the world of X402, you're going to have a lot of, robot baristas. They're not really going to be baristas, but these bots too, the use cases can benefit dramatically from privacy and confidentiality. When your bot's out paying and doing all these things, you really want that tracked back to your identity. In some instances, no, but in some instances, you don't really care. In many instances, you do. You do not want this information exposed. So we're working really hard to be able to bring this byte phase 2 privacy to agentic efforts with X402. All right. So, hey, it's been my pleasure. If anyone has any questions, we'd love to handle them. You can follow me there at X and SKALE and the Fair blockchain. And yeah, thank you. By the way, Jack is sponsoring SKALE of the event, so I'm incredibly grateful for Jack and his crew at SKALE. They've been sponsors of my events going back to, I think, 2018. So I'm grateful for all your stuff. So one question, and then connecting. By the way, round of applause for Ken. Come on. Okay, we got a question in the back. Is that agnostic with AWS Nitro too for redundancy? So in the short term, no, unfortunately. And I think there's also a big movement into TDX from SGX. There's just a lot of nuances with the smart contracts and the work we're doing with Solidity that is very specific to SGX. One nice thing is a lot of the issues with SGX, when you incorporate multi-party computation and blockchain dynamics, it's really, really difficult to actually have anywhere near real-world meaningful attack vector. But definitely something we're thinking about. And I know Google and a lot of the other providers have products, and I think a lot of it's moving into TDX. But we're just trying to ship this out, and then we'll get more configurability. Great question, though. Thanks. All right, everybody. Appreciate it. Thank you.